do.
Here we go. I've actually titled this High Reliability Safety because as we go into the talk, you'll see that high reliability organisations, or HROs, is actually a bit of a misnomer. It's not a great term, but what we're actually talking about are organisations that have got remarkable standards of safety performance, despite the fact that they are dealing with high hazard, high risk situations. So what I am just going to do is just go to this page here. I'm just going to ask everyone a quick comment. So go ahead and type into the comments box there. Have you heard of high reliability organisation, or HRO? Is that a term that you are familiar with? Yes or no? Just go ahead and type in the box there.
Nothing come through yet, but I'll add in a no. I've no idea what it is.
Okay, feel free to add your comment there. So I'll work on the assumption that many of you, or at least some of you, have not heard of this term. Forgive me if you are familiar, but high reliability organisations is very much a term that was first researched by social science or social scientists, and it's a social science construct. And essentially what they observed were that there were a number of organisations out there, this was about 20 years ago, that, as I say, had very, very high standards of performance from a health and safety perspective. So they were organisations, the original ones were organisations like the Navy, aircraft carrier operations. There were some civil aviation, and as well as some energy organisations. And this led to a bunch of research and a number of key documents. So this is one that you can access free of charge that was published by the HSE. There is a download link to the PDF where they were reviewing, what is a high reliability organisation and what's the science that underpins it. And it has gone through a number of evolutions. This was a groundbreaking book by this chap, Andrew Hopkins. Andrew Hopkins is a social scientist, and he is one of the key, if you like, founders of the research into this area. And that's a great book where he looks at a number of HROs and what are their defining features and what can we learn from an HRO in terms of applying it to our own organisation. And then finally, there's another free resource that I'd point you to. It's a podcast that it's been produced by Australian authorities. That basically what they're now looking at in terms of mining and quarrying is that they're asking those sectors to adopt HRO principles into their operations. So that is a link to a podcast, a 6-series podcast. It's very well produced, and it unpacks and explains what an HRO is and how the principles might apply to your organisation. So there's three sort of free resource, or 2 free resources for sure. What I just wanted to also point out to you is that there is another discipline out there called safety resilience or cognitive engineering. And the godfather of certainly cognitive engineering was this chap, Jens Rasmussen, who you may have heard of. He was a cognitive engineer. That was his background. He worked in nuclear energy, and he published this groundbreaking paper, Risk Management in a Dynamic Society, a Modelling Problem. And the gist of this paper was to say that our current approach to health and safety management is somewhat limited, and that we need a more, as we'll see, systems-based approach to be able to deal with the very dynamic and complex situations that modern workplaces find themselves in. Now, more recently, there's a number of high-profile authors, researchers, who have all been fundamentally influenced by Jens Rasmussen. Here is one. one of the names on this book is Sidney Dekker. I'm sure you may well have heard of him. This is a landmark publication, Behind Human Error. And what they're pointing out here is that human error is a symptom, not a cause. And if you want to really get safer behavior in the workplace, you've got to go underneath the surface, or in this metaphor, behind the curtain. And how can you do that? What they're talking about in this book is very much a cognitive engineering approach, which is based very much on HRO principles. So there's a big crossover between these two disciplines. The main difference is this is a bunch of social scientists, and this over here are a bunch of engineers, but they definitely cross over in the middle. Here is another landmark book that you're not aware of, Safety 1 versus Safety 2 by Eric Honeygel. Again, Eric Honeygel has been deeply influenced by James Rasmussen. You could call all of these Rasmussians in their view of the world and what they're talking about in terms of some possible ways forward to improve health and safety management. Now, these various authors have come up with different initiatives that you may have heard of. Safety Differently, Safety 2 that we've talked about from Eric Honeygel. There is the whole area of James Reason and safety culture. He was one of the first to use the term safety culture. And there's also a whole discipline area of what's so-called human performance, which often gets abbreviated into human and organisational performance, or HOP for short. The point I'm making is these are all out there, but if you actually go underneath and look what they're talking about, there's a lot of common ground, and they all cross over into very similar areas. Although there are differences, there's a lot of common ground here, and it's the common ground that I'm interested in, and I will start to talk to you today about. So let's have a closer look at what actually do we mean by a high reliability organization or an HRO. As I said, one of the first organizations that the social scientists went in to look at was the American Navy aircraft carrier operations, which is just a unimaginably high hazard, high risk environment. And yet these jets are taking off and landing on these aircraft carriers, with a very, very high safety record. There's remarkably few incidents given the kind of situation they're dealing with. So what Andrew Hopkins and others, through this research, they've defined an HRO based around what they call 5 principles. The first one is preoccupation with failure. And what they mean by that is these organizations have an obsessive culture when it comes to being able to look at their operations, and they're never satisfied with what they're doing. And even when they're successful, they're asking the question, what could go wrong here? And that's just a deeply rooted cultural aspect of the way they operate. They're always looking for what might go wrong. Preoccupation with failure. Second one is reluctance to simplify, which means that they resist the temptation to look at incidents when things do go wrong, near misses and accidents, and they really do go into a heavy duty explanation or investigation of what went wrong. They really get down deep underneath the surface, and they avoid simplistic explanations. There's what's called a commitment to resilience, and by this, it's fundamentally, it's about learning from your performance, but it's also about giving your people skill sets to actually deal with dynamic situations. You can never predict every scenario you're ever going to encounter. And the idea of having a set of documentation that gives everybody everything they need is, for many complex situations, totally unrealistic. So resilience or resilient performance is not about avoiding error, but helping people to deal with errors and to recover safely. And the civil aviation sector, as an example, have a whole stream of training for frontline aircrew to help them become more resilient when things do go wrong. Sensitivity to operations is the fourth one, which is basically they're able to detect issues at a much higher level of fidelity. So many organizations have got near-miss reporting systems. And if you can think of it as, obvious near misses or near hits, when something happens and whoa, that nearly went wrong. These HROs are going far further up the stream, and they're looking even at small deviations, any deviation from what they would consider to be standard operating procedures would trigger an incident investigation. So they're very sensitive to what is actually going on at the sharp end. And then the fifth and final, which is in my book, perhaps the most important, deference to expertise. And what this means is that they invert their hierarchical organizational structure. It's the people who are doing the work who are given the authority and to investigate, to deal with the issues, to raise their hand, and they are given the authority when it comes to health and safety. And it's seen then that the management layers below that are there to support them. And if someone says there's a problem at the sharp end, it's taken very seriously. So one of the key things that particularly Jens Rasmussen and all of his disciples have pointed out is out there, we have fundamentally two different types of systems. We have complicated, a coffee machine. That's a complicated system in that if you push a button, you can predict certain things are going to happen with high degree of reliability. Whereas on the right there, that's a complex system. A jar of mayonnaise, you get some ketchup, you stir it up. It is impossible to know where the mayonnaise, the ketchup is. You don't know what's going on underneath the surface. And particularly, the more it gets stirred up, the more complex it gets. And these two types of systems are fundamentally different and require different management approaches. So metaphorically, that is a complicated system. Straight lines, linear relationships, and that's a complex system. The lines are not straight, the relationships are not linear. So what one small change somewhere in the system can have big impacts somewhere else. It's highly unpredictable, very difficult to model. So this guy, Ross Ashby, in 1956 came up with this groundbreaking insight or law, Ashby's law. He said only variety can destroy variety. And what he meant by that was simply this: if you imagine that as a work system metaphorically, then your people are going to require that kind of set of resources, skills, tools, training, and the rest of it to deal with that level of complexity. But as the complexity increases, your people are going to need more capabilities, more resilience in order to deal with that level of complexity. The more complex, the more your people are going to require different types of tools and skills. So remember, we can never model all of a complex system. Probably the best we can do is look at the outside of it and see what's happening, but it's very difficult to look underneath. But despite that, we have this thing called work as imagined, and that is all your documentation, standard operating procedures, safe systems of work, permits to work, all of those things that says this is how we imagine work should occur in our organization. Then you have this concept of work as done. Now, the interesting thing about this is when we do investigations from near misses and accidents, we often find that there's a mismatch between work as imagined and work as done. And that sometimes there may only be minimal overlap. And we start to think, why was work as done so different from what we did as work as imagined? And even if there's good overlap, there's often lots of things that are out there occurring that are not in our work as imagined. Now, why am I telling you all of this? Well, these are facts of life. This is based on fundamental laws of nature, i.e. complexity theory. And the reality is that we cannot predict everything that is going to happen. We cannot put it into all of our documentation. The only way we can deal with complexity is to give our people resilience to deal with the unpredicted and to deal with everything that's not in the red area, because the red area is never going to be the complete picture. Unfortunately, when we then do an investigation, a lot of people's mindset is, if it wasn't in the red area, you shouldn't have been doing it, despite the fact that it's the green bit that makes the operation work on a daily basis. And the point is this: HROs understand all of this. They understand complexity theory, they understand systems thinking, and they have utilized these management principles to great effect to achieve really high standards of performance. And this is how they do it. So what I wanted to do is just give you a couple of examples of high reliability organizations and explain to you, just give you some insight as to how they've applied these principles. So here is the first one, Alcoa, which is a global manufacturer of aluminium. They have foundries as well as production processes, and they make everything from tin foil in your kitchen through to aeronautical parts. And in the late 80s, this chap here, Paul O'Neill, became the new CEO of Alcoa, and he took over the organization at a time when it was in very bad shape. It was losing money. It was considered to be a very old-fashioned manufacturer. And on his first day, he went, as luck would have it, he had to go to a Wall Street investors meeting to report to these analysts what was going on within Alcoa. And his opening line was, he said, "I want to talk to you today about safety." And everybody in the room kind of stopped and looked at each other and said, "What is this guy talking about? This is a Wall Street investors meeting, and he's talking about safety." And Paul O'Neill went on to say, he said, "Look, what I want you to know is that our safety record within Alcoa is so bad that every year we are seriously injuring large numbers of workers to the extent where they have to take considerable time off work, and sometimes they never come back." And one of the participants put the hand trying to get the meeting back on track, and he said, "Look, could you tell us about the stock control at this aviation subsidiary that you've got here?" And Paul O'Neill was having none of it. He said, "Look, I don't think you've understood. If you want to know how this management team is doing, then you should look at our safety performance. Because if we can't do it for safety, you should be damn skeptical that we can do it for anything else." At which point, half the room stood up and there was a stampede out the back. And these analysts, these investors, all getting on their phone saying, "Sell, sell, sell. They put this crazy guy in charge of the company. He's going to kill it." So let's have a look at what actually happened. Well, he was there between 1987 to 2000. And at the end of his period in charge, Paul O'Neill got his wish. His wish was that Alcoa would become one of the safest employers in the world. And he certainly got that. He went from an injury rate of 1.86 to 0.2. And it's more recently come down to 0.125, so it's continued. So it had a massive improvement in safety performance. But interestingly, that was also a huge commercial success. During his tenure, the value, he added something like $27 billion to the value of the shares in Alcoa. So he transformed this organization, and he transformed it through health and safety management. That was the overt signal to everybody outside and inside the organization. And if you actually look at what he was doing, NASA have done research into Alcoa and others, and what they identified was, in fact, that he was using high reliability principles. You can actually then go down to individual plants. This is one of their plants in America, and this is what they achieved: significant reductions in injury rates, but also there was a significant improvement in workflows, equipment, better working methods, reduced packaging costs. So one of the messages is, there is this old adage that high health and safety performance leads to good business performance. Well, the causal relationship is actually the other way around. It's high business performance that leads to good safety performance. And what Paul O'Neill knew was that if he could start to change one thing, and he chose it to be safety-related behaviours, he knew that if he could genuinely improve those behaviours, he would also get this improvement in business performance. Now, it's not always true that safety and business come hand in hand, because there are sometimes conflicts, but fundamentally they do go hand in hand. And these are what are called keystone habits. Health and safety is one keystone, quality, productivity, efficiency, these are other keystone habits. And you can't switch any one of them on or off individually. They all come together as a package. So there we go. They improved productivity by 87% during his tenure. So how did he do this? What was his process? Well, Paul O'Neill went out and he actually visited every single Alcoa plant around the world, 350 of them. So it took some time and it was a big undertaking. And at every site, he sat the workforce down and he said, I want to talk to you about safety. And what we're going to do is, if we identify a safety issue, we're going to fix it, and we're going to fix it straight away. And then he would turn to the managers, the supervisors on one side and say, your job is when it gets reported, is you got to fix it. And we're not actually going to budget for it. We're going to fix it as fast as is humanly possible. And then he turned to the other side, the front line. He said, your job is to identify these problems and report them. And by the way, if you have any problem with that, here's my home phone number. And he literally gave out his home phone number. This was before mobile phones. And again, they thought he was mad. He's going to be getting, their workforce is into the hundreds of thousands. He thought he was going to be inundated with phone calls. He actually only got a very small number, because it was clear to everybody that this guy was serious about making a real improvement at the sharp end. He did get a few phone calls, he reacted to them, he sorted out the problem, and he said then the message went out, he's serious, we've got to do this. So he said that there was then an Alcoan mind shift. And one of the key things that they realized during this process was the bowl of mayonnaise concept. It is not possible to design a perfect system of work in advance. You can only discover it. So it's like an archaeological process, and you have to have the active participation of the people doing the work to help be sensitive to what is going on, the changing work environment, feeding that information back. You've got to give them the authority to do that. You've got to listen to them, and then you've got to develop and evolve your work system based on that participation. And that's fundamentally what they were doing. And he said this was a seminal insight. So their secret sauce was employee work as done knowledge. Harness it, collecting that, harnessing it and using it. But not just that, it was the speed with which they did it. So I'm sure in your organization you've got these kinds of systems, but as we'll see, it's the speed with which HROs are doing it. They are doing it in hours, days, not weeks, not months, and certainly not years, and they're doing it consistently. So here's one quote from him. He said, I said, we need to have a system that is worldwide, that we learn from every day, with the expectation that it will be posted in 24 hours, so that every one of our locations, 350 of them around the world, will act on that information if it is pertinent to their circumstance the next day. So we speed up and we make every element and every individual in this company part of the notion of continuous learning, continuous improvement. So there's a very good book, if you want to learn more about that, it's called The High velocity edge by Stephen Spear. And what he's talking about in that book are high reliability organizations. Alcoa is one of them. And he's talking about all the principles I've just introduced, but also, as in the title, it's the speed with which they manage to do it that really leaves all their competitors in their wake. So when we come back to these 5 principles, what we can see is that Alcoa had this massive preoccupation with failure. Where are things not working? Where can we improve? They had sensitivity to operations. They recruited everybody doing the work to look, to report, etc. And there was massive deference to expertise. If anybody put up their hand, they were listened to, that the issue was acted upon. So here's another one, Toyota. 2 pillars on which their success, they are the world's most successful currently car manufacturer. 2 big principles that they use, that they say they use: Kaizen, which is a process of continuous improvement, and the second one, respect for people. So these are very, as you can see, HRO-based principles. So by 2007, they posted record profits and had become the world's top manufacturer. And then this happened. In 2010, this family, this chap here with his family, was traveling along in a Lexus, a Toyota Lexus, and there's a pretty harrowing call. It's on YouTube, but you can actually hear this guy reporting into the police control center that his accelerator is jammed full open and that he can't stop the car. And then seconds later, the car crashed and he and his family all perished. Now, this was not an isolated incident. There were many other fatal accidents involving Toyota cars. And if we look at the figures, in 2009, Toyota recalled something like 4 million cars, and by 2010 that had risen to 10 million, and by 2011 a staggering 20 million vehicles had been recalled. Why? Because of faults in floor mats, brakes, accelerator pedals, engine software. There were a myriad of quality issues, and as we've seen, a number of them were absolutely safety critical, and a number of people lost their lives. So the question is, how did the world's preeminent auto manufacturer get into such a mess? So let's come back to these 5 HRO principles and take a closer look. And these are some quotes from the from Toyota executives subsequent to the investigation. Preoccupation with failure. Well, they basically started to say, we will handle all the issues at head office. You down there in the factories, this is none of your business. We'll handle it. Keep your nose on that, what you're doing. We'll handle it. It's just stay out of it. And they said that this approach was hubris born out of success. They'd become so successful, they'd become complacent, and they thought at head office they could predict everything that was going to happen in this highly complex situation. And they were led into what's called the fallacy of centrality. And the fallacy of centrality is simply this: if you're sitting at head office or in the top of an organization and you're not getting any bad news, that means everything is okay. And in reality, most of the time, no news is bad news. It just means you don't know what's going on. Sensitivity to operations. They started to blame accidents on customer errors, literally. They started to explain them away because somebody had driven too fast or mistreated the car. They were not looking at their system and their product critically. And I'm sure you're familiar with this concept. If you start blaming people when things go wrong, you will learn nothing. Deference to expertise. Well, you've just heard, they literally were saying to frontline people, because frontline people were putting their hands up. All the signs and symptoms were there. People said, there's a problem with the brake pedal here. there's a problem with this engine software. This is none of your business. We will deal with it. So there was complete shrinking of deference to expertise. Commitment to resilience. The Toyota exec said we did not do a very good job at sharing information across the globe. So they knew about a problem in one region, like for example in the UK, but the learning from the UK market wasn't shared anywhere else in the world. And they were just looking for a very simple explanation for what was going on. They focused, they said, too narrowly just on technical issues, and they were not looking at the complete socio-technical system. So they got these 5 principles badly wrong, and it led to disaster. This story ends in a much more positive way. Then in 2011, they recommitted themselves in a new policy statement for the following decade to reintroduce the principles that had already made them successful. And they are now back to a preeminent position. And they are doing it through Kaizen, respect for their people, and these HRO principles. But they went from hero to zero, and they've come back to a very good status. So in the time that's left, let's just have a closer look. What you can see from HRO principles is that the central common theme of an HRO is its ability to learn. Its ability to learn from work as done, to take that experience, and by learning, we mean changing, doing something differently as a result. It's that ability to learn that has achieved these remarkable standards of safety performance. So let's take a closer look at this concept of organizational learning. This is a seminal book by this chap here, Peter Senge. He is a systems-based thinker, and he wrote this book, The Fifth Discipline, the Art and Science of a Learning Organization. And he goes, as you might imagine, through 5 principles. And the 5th discipline, as he calls it, is systems thinking. It's the ability to think in terms of the bigger picture and how the whole thing comes together. So let's have a look what we mean by that and what we mean by systems thinking. So here's a steam boiler. Now, steam boilers used to explode quite regularly. And then over many years, from the 19th to 20th century, subsequent design improvements of various components on steam boilers have made these systems, this product, very safe. Things like, thicker walls to the boiler, more reliable welding on the joints, and then safety systems like pressure release valves and so on. So we can make an individual component within a system very safe by looking at the individual components. But let's now imagine a system. So we've got a guy whose job it is to run this boiler, it's to look after it, maintain it, and he's very experienced. We've given him training. He knows how the boiler works and how to keep it in tip-top condition. And let's say this boiler is heating a couple of buildings like this. And we can see from the pressure valves, it's well within its safety margin. All is good. Everybody's happy. It's safe and efficient. But then let's say the client says, well, do you know what? We're going to add another building that this steam boiler is going to heat. And now our boiler is starting to work a lot closer to its safe boundary, as we call it. So we've come very close to the safety boundary, but it's still operating safely. And we've still got a guy there keeping a close eye on it. But let's say there's some budget cuts and we say, well, we don't need a guy there all the time looking after it. And anyway, he's about to retire, but we won't replace him with such a senior person. We'll just put a part-time guy, give him a bit of training and see how he gets on. And then one day, there's a bit of a malfunction in the boiler because maybe we haven't kept it as fully maintained as we should have done. The pressure goes into the non-safe area, and bang, we get an explosion. And this does happen. It's pretty rare, but it happens. So what we can see here is that although we had an individual component within the system that was safe, The system itself was not. So a reliable component does not equal safe. You've got to look at the whole system, and this is what we mean by systems thinking. Another issue with systems is things in complicated systems work in straight lines, as we saw. One thing leads to another, leads to another. Press the button and you get a cup of coffee. But in complex systems, you get what are called feedback loops. So take behavior and attitude, a very simple feedback loop. So we know that behavior affects attitude, but attitude affects behavior, and around and around we go. So what is causing which? Is attitude affecting behavior? It's both. And this is the deal with complex situations. We've got feedback loops going on. So think about a slinky. If I just stop presenting for a second and show you this slinky. There's the slinky, and it goes up and down. So the question is, what's causing the slinky to move like it is? What do you think is causing that slinky to move? Well, I'm not going to ask you to type in the comments box because there's a bit of a delay there. But a common response is, Ian, well, it's obviously gravity. Gravity is pulling it down. Well, let me show you this. If I take a bulldog clip and I attach it to, say, get on there, the top bit of the slinky. There we go. A bit more. There we go. And I now let go of the slinky. So there we've got a bulldog clip. Very different behavior. Very different. All right, the bottom bit's still bouncing up and down. But as a system, we've got very, very different overall behavior. So the explanation for why is the slinky moving like it's moving is not gravity. It's something else. Let me come back to my presentation. You seeing the screen again, Julie?
Yes, we are.
Great. So the answer is it's the interconnections, it's the interrelationships between one little bit of the slinky and the next. That is what is causing the slinky to actually move like it is. And by putting the bulldog clip on the top bit, we've changed the interactions between some of the components, and therefore the overall behavior of the system changes. And this is very, very important to management of health and safety in complex systems. We need to be able to understand the system as a whole, and there are ways of doing that, or there are techniques for doing that, which, by the way, are not commonly taught in a lot of fundamental health and safety qualifications like NEBOSH, IOSH courses and others. They're not generally taught this type of understanding. Now, another important concept in systems thinking is what's called emergent behaviors. So here we have a car. And what is an emergent behavior? Well, an emergent behavior is the thing that you get from a system, but which is not in any one component. So one of the emergent behaviors of a car is it can get you from A to B, and it can transport you over long distance very efficiently. You know, but the ability to be transported is not in the wheel. If I took the wheel off and gave you the wheel and said, there you go, it wouldn't take you anywhere. You'd have a big job. And the same with any individual component. It's only when all of those components come together and interact that you get the emergent behavior. So think about this. Let's do a thought experiment. Let's say we want to build the world's greatest car. And what we're going to do is we're going to go out into the market and select different products, different components from different cars. Because, you know, clearly a Maserati has got the best engine going, it's the most powerful. And maybe a Land Rover's got the best wheels and so on. And what we're going to do is take the best components and we're going to fit them all together. So the best body, the best engine, the best door, the best wheels. Question then is, what do you get? Well, the answer, clearly, you can see in front of you, you don't even get a car. Why not? Because the components don't work together. They don't fit together. They don't work as a system. The problem comes with many organizations, though, when things go wrong, is they tend to look at the individual components rather than the whole system. And that, in a complex system, is a surefire way not to learn the real lessons of what's happened. That is a simplification of what is going on, and it requires systems thinking. So just let's apply this to your area of responsibility. In terms of health and safety management, you've got lots of things going on: training, online, offline, risk assessments, incidents reporting, contractor management, inspections, reviews, operating procedures. This is a system, and there's interactions between all of these components. Question for you: do you think of this as a single integrated system? Are there connections between these different components? And are those connections so good? Paul O'Neill was talking about using online technology back in 1987. Just think about training. A lot of organizations are still using digital paper, as in Excel sheets, let alone linking this data out into all these other areas, automatically learning about the interaction. Imagine the emergent behaviors you could start to get from a truly integrated system if it was analyzed to work in an integrated way. Incident reporting to work as done. Are you really getting to what is actually going on? And is that actually being fed into incident reporting? So think of it this way. We looked at a car. Here's a car. It's not a great car, but it works. It gets you from A to B. What I'm pointing out to you, though, is you could build a car like this. Not only does that car move faster, but it could start to give you emergent behaviors that you're not getting at all at the moment. Obviously, the metaphor there was time travel. I don't think we're going to get time travel anytime soon, but there are many other emergent behaviors that HROs are getting from their work systems that everybody else out there is struggling to achieve. So that today concludes my my speech on high reliability organizations. And just to conclude, that is why I don't call it high reliability organizations. What they're actually talking about is high reliability safety. The whole reliability term is a little bit problematic, because what you should be looking at is not individual components, it's the system. Just to finish off, here are a couple of free resources for you if you'd like to learn more about my thoughts on this matter and how you can perhaps begin to harness them in your organization. As part of today, it says 1999, I will actually give you a free copy of my book. That's a physical copy, a real book. I'll post this link in a second, and I'll also send that over to Julie. So if you go to this link, you can have a completely free copy of my book. I talk in that book about Alcoa. I talk about other high reliability organizations and how they're using their health and safety training systems to achieve not just safety success, but commercial success too. So that is a free copy of my book. I also have a free continuing professional development webinar coming up on the 27th of July. This is a 1 hour where I'm starting to look at HRO principles in more detail, how you can apply them. This is a part of a sequence of webinars that I've been doing. This is actually part 5. If you sign up, you will get immediate access to parts 1, 2, 3, and 4. As I say, this is high quality, completely free. What I'm trying to do here is, after 30 years of professional practice, trying to just give back to the profession and share what I've learned. So that's another free resource there for you. So there we are. I'm going to stop sharing and hand back over to Julie. Thank you so much for listening. I am watching. I hope that has been interesting and that hopefully you've learned something new. And I think we have a few minutes if anybody does have any questions.
Thanks for that presentation, Ian. It was fascinating. I've learned a lot today. If you want to provide me with any links, I can send them out to people.
Yep.
We send a follow-up email to those who attended. I think it goes out tomorrow. I'll be happy to include those
I will
links.
definitely do that. I have just also posted in the comments box. The first link there is to the webinar, and the second link there is to my book, but I will also send those to Julie if you can't see those.
Fantastic, thank you. We had one question early on, but I didn't want to interrupt the flow of your presentation from Victor. You mentioned some reference materials from the hse.gov.uk. Are those free to download? It was a very
They are
beginning.
indeed, yeah, and I will also include those links to you. There were two, in fact. One was to an HSE white paper on high reliability organisations. So again, I've just posted that in the comments box there. And the other one was a podcast of 6 podcasts about high reliability principle approach by the Australian government in the mining and quarrying sectors. And again, I've posted that. They're all free. All 4 resources are free.
Okay, great. So we've got some more comments really and compliments. Someone saying they couldn't figure out how to use the chat, but a great presentation, incredibly generous offer. Thank you for the information. And then one here from Tony, many aspects to take away from this great presentation, and thank you so much for the free items you mentioned, as many will point out, including in your presentation, people completing the task must be involved. And what is the best way to achieve this? Sorry, I can only see part of that question. I'm kind of making it up as I go along. I can only see half the question, but there's so many comments thanking you for a great presentation. So I'd like to thank you. I've learned a lot today. I'm sure everyone else has. And I just wanted to remind people that the next South East Branch webinar is on the 13th of July, and it will be an update from the HSE. So I'd like to thank Ian again for giving up his time today, and I'd like to thank you all for attending, and I hope to see you at the next webinar.
Thank you so much. Nice to meet you all. Take care.
Thank you.
And remember, learn something.
Definitely.